The goal of this presentation is to cover the disposal and release, the impact reduction, and the REM compliance with regard to solvents used in the lab. We want to make it clear that we're providing suggestions, and we want you to take these into account with your personal research in mind. You may have seen this chart before when we talked about plastics, and now we're going to look at it with regard to solvents. It's important to understand the ultimate fate of the solvents you dispose of, to understand the impact they may have on the environment. So first of all, you're going to dispose of a solvent ultimately. You're going to use it, and then you may store it, but ultimately its final fate is being disposed of. And there are several paths that you can dispose of it, so there are several different places it may end up. For instance, if you dispose of it in the fume hood, it goes straight to the atmosphere. There is no treatment in the fume hood. If you mark something as hazardous waste and give it to REM, then there are several different things they do with the chemicals they receive. It really depends on the solvent. A lot of times they'll incinerate it. So also collection services, that means either recycling or trash. And that's, if you separate the recycling, it'll go to the recycling facility. But everything that goes in the trash is probably going to end up in a landfill because we're in Indiana. Disposal through the sink will go to a wastewater treatment plant where they can treat the water and then return it to the river. But keep in mind that they can't treat for things that they don't know about going into the water. So that's especially important with regard to lab work because there are things that aren't naturally going to end up in the water that could potentially end up in the water if they go down the sink. So that's why it's important to follow REM's guidelines as to what can. Why it's so important to be aware in the fume hood is because there is no treatment when volatile chemicals go into the atmosphere. And that's protecting everybody inside because, you know, the room isn't filling up with volatile chemicals that you're breathing, which is awesome, and that's the point of the fume hood. But it's going right into the atmosphere and kind of mixing with everything else in the atmosphere. So it's important to be aware that there's no treatment in the fume hood. And so they recommend that chemical storage should be, if possible, in ventilated cabinets instead of in the fume hood for the long term. Like if you're going to keep it for a day or a week or something, just put it in the ventilated cabinet overnight instead of keeping it in the fume hood, because the fume hood's working really hard to get all the volatile compounds out of there. And so it could take a little more than you want it to, which is also a waste of solvent. Also, it's recommended that you cap them very well, and hopefully the caps have a plastic liner of some sort, and maybe even parafilm. I think that's what it's called, the plastic that you wrap around the cap. And then only open it when you're using it. So if you walk away for 5 seconds, just cap it. And this may not seem like a lot of waste because you don't really see what's coming off it before your eyes. You can't watch it like go down instantly, but if you were to look at the amount of solvent that you purchased and then the amount of solvent that you dispose of to REM of that same bottle by volume, you'd probably notice this little difference, right? And that's the part we're concerned about, because with each bottle of solvent you buy that is going down a little bit because it doesn't all go to REM, the volume is less. That little bit of volume that's less ended up somewhere in the environment, probably like through the fume hood, for instance, as I was just mentioning. Next, I will talk more about radiological and environmental management, what I've been calling REM at Purdue, and their side of things. So that's hazardous waste treatment. As mentioned before, REM treats the hazardous waste that you use in your experiments. So one idea to keep in mind is that less is better. Experiments on a smaller scale will use less solvent, they're going to cost less lab user exposure to the chemicals, less evaporation losses in the fume hood because there's less solvent. Another recommendation that goes along with this is not to buy in bulk, because you don't really save money, as it kind of may seem. because you still have to dispose of all the solvent. Also, sometimes experiments change, and then you have all this solvent and you have to get rid of it somehow. If you only need a little bit of solvent, ask around to see if other labs may have it. Finally, store less, even, to avoid the safety problems that having a lot of chemicals in the lab may come with. And if possible, use less, whenever possible. When disposing of waste, try and separate hazardous and non-hazardous. This may come easy to some people, but just remember that as soon as you put a hazardous waste in a gallon of water, even a little bit of hazardous waste, now it's got to be treated through REM, and now it is a hazardous waste. So this especially applies to halogenated compounds, and acids and bases, but I think we are required by REM to separate those anyway. When it comes to substitution, there's a program out there called the Green Alternatives Wizard, and that's the website on here. And it's by MIT, and it's free, so at least check it out. And they say, this is kind of a quote from them, "The alternatives provided do present a starting point for researchers to consider alternative methods to their own research that would reduce, if not eliminate, the use of a particular hazardous solvent." So you can consider what they're saying. You basically, if you can see from this interface, it's kind of the picture on here, you can either replace a chemical or a process, or you can look up an alternative chemical or an alternative process. So it's pretty useful. Just check it out and see if there's anything you use on there. It might be worth it. Finally, an inventory is extremely useful, and this may not seem at first like something that could be helpful, but it could be anything from a Google spreadsheet to software, and there is a program that Stanford has out there, and I have that on the final slide of this presentation. So in your spreadsheet, you code the chemicals so that it can be identified in a database, and all the lab members have access to it. All the dates of the containers should be on there, and then it should be manageable by inventorying only very large solvents, largely used solvents. Then you have to keep track of empty containers and remove them from the list, which is also kind of another burden. But you could have 1 or 2 rotating people in the lab taking charge of it. And it's a plus because you avoid buying too many chemicals, and also, let's say someone graduates and the chemicals they were using for their experiments, no one really knows what they are, how old they are. These are the kinds of chemicals that get turned into REM all the time, and then they have to be disposed of, and it's a huge waste. So don't contribute to that waste, especially if it can be avoided. Next, I'll talk a little bit about disposing of something through the trash or recycling it, but from the perspective of solvents. So it's kind of a mess to determine whether or not solvents within a plastic have contaminated it to become hazardous. And the EPA, I've included a link to this at the end of the presentation, so if you're really concerned about it, you can definitely look it up, but I'm guessing you probably know. But if it becomes a toxic waste, an acute hazardous waste, ignitable, corrosive, reactive, or a toxicity characteristic waste, that's when you got to be concerned when you're using it, and it could probably contaminate the plastic and be considered hazardous. If not, you can dispose of the little bits of solvent that are left in the plastic through the trash. But before you do that, kind of consider, is the solvent volatile? And then maybe you want to rinse it before you dispose of it, and then dispose of that rinsed material through REM. So that's because when you think about it, if you're disposing of something volatile, it's ultimately just coming back into the room for you to inhale. Also consider the packaging that comes with your solvents that you buy. Cardboard and paper are much easier to recycle than styrofoam, and so maybe try and reuse styrofoam when you can. Finally, I'll talk a little bit about sink disposal through the wastewater treatment plant. If you go to this link and you look at the document on page 20, REM has a list of solvents that are approved to go down the drain in small quantities. And small quantities is not a definitive term, as I'm sure you know. And so think about what a small quantity is to you, what you would put down the drain, and think that's okay. And then add that up over the course of a month or a year or the length it takes to get your PhD, however long that may be. Depends on the person. Then multiply by all your lab mates. So you begin to realize that this is yet another tragedy of the commons situation. And what I mean by that is it's something that if we all did it, it would be a very bad thing. Also, I wanted to mention that ethanol and methanol are not on this list. Take that for what it's worth. Also, nanoparticles are not on this list. Since we don't know what they could do to the environment, REM recommends that they all be treated as a hazardous waste. Furthermore, the chemicals on the list can still have an impact on the environment. They're only on there because they're legally approved. So it's based on EPA lists of compounds. But, everyone knows that the EPA does not have all the money or time in the world to be able to look up every single thing and know everything that's not toxic. So it might be a good idea to do a Google Scholar search if you're using a chemical a lot and you're putting it down the drain a lot. And see, are people reporting issues about it? Are people studying the toxicity of it? Finally, for what it's worth, you might look up micropollutants as an emerging issue. And think about that when you put things down the drain in small quantities and how that could add up over time.
As most of you probably already know, REM has guidelines on hazardous waste disposal that are available at the link provided. These guidelines provide a list of chemicals that are acceptable to be disposed of down the drain in small quantities, and this list can be found in Appendix E of the document. Also, there is a section on liquid chromatography waste. This section mostly states that all containers that collect the waste must remain closed while the unit is being used. Purdue has received past citations from the EPA on this issue, so it is really important to them that it is met. Also, containers containing chemicals must be labeled clearly and marked with words that describe the contents of the waste. They have had issues in the past of it not being clear what chemicals are inside of containers and if those chemicals are still pure and good for use or if they need to be disposed of. REM also has a chemical redistribution program. They take materials that are in the original container and have the original labeling and will redistribute them to people who would like to receive them. So if you are interested in this program, there is a list of common chemicals and you may contact REM to see if those chemicals are available.
So for those who are interested, here are some of the sources that were mentioned or used in the presentation. The first one was used in the presentation. You'll notice it's from 1999. And you'll notice that Maryland has had environmental guides for labs since 1999, which is pretty cool. The second one's from MIT. We use this a lot in the presentation. That's also where you can find the green alternatives wizard I was talking about. The third one, this is the ChemTracker Stanford created, so that's a chemical inventory program, I'll call it. 4 is the EPA hazardous waste identification if you're having trouble identifying whether or not the plastic it's a lot of stuff, but I mentioned it when I was talking about plastics and that are contaminated with solvents and have potentially become hazardous waste. This is where you would determine that. And then the REM hazardous waste disposal guidelines, that's where you would find the list of chemicals that can go down the drain and a lot of other really fun stuff that was mentioned. Finally, number 6 is just one suggestion. There's a lot of literature out there, but this is a micropollutant paper. And then number 7, that's just where the pictures were from, BWR. Thanks for listening.